Hi guys, so today I'm going to show you about hyperpolarization and depolarization and an equation that you can use to figure it out. So I briefly mentioned action potentials last night, but today I'm going to go into more detail about them and describe how they work. I'm also going to show you the equation for calculating charges associated with action potentials. When a neuron becomes excited, sodium rushes in and potassium rushes out due to the concentration gradient which diffuses ions. You could think of the concentration gradient as dropping ink into a glass and over time the water turning black because it diffused out. But if you were to put a barrier in the glass, dividing it vertically in the center, and then only drop ink in one side, then because it had a barrier it would not diffuse, because only one side would turn black but the other one wouldn't. And this is the same way with neurons, which have open channels and gated channels. Ink or ions diffuse out in a gated channel if a charge, an electrical charge opens the gates due to the graded potentials that build up on the dendrites. I'll talk more about graded potentials in another video. So the charge travels down from the axon hillock, the part right after the body, and then it shoots down the axon to where the axon branches to the terminal buttons, which release neurotransmitters such as serotonin and dopamine. They then travel through the gap or cleft which bridges from the axon to another dendritic neuron and then binds at a receptor site. Then the excess neurotransmitters taken up or metabolized. But how do these chemicals become released? They're put in these things called vesicles, and they travel down the microtubules in the axon. And so these vesicles are kind of like Tupperware. And the cell produces them and then packs the neurotransmitter in them. And then through a process called exocytosis, they're released out through the end of the cleft, traveling through the synaptic gap, or traveling through the cleft, and then they go and they bind to the receptor site. And there's specific receptor sites for each chemical. And some other chemicals can mimic, certain things. Receptor sites, so they can bind, like for instance nicotine binds to acetylcholine receptors, which gives it its narcotic effect. But so what if I want to know the difference in charge between the outside and the inside of the membrane? Or what if I want to know the membrane's resting potential? Or what if I just want to know the charge? So the equation we'll use is, Vm is equal to V in subtracted from V out. And the subscripts in the in and out, tell us exactly what we need to know and what numbers to use. So Vm is equal to membrane potential, Vn is equal to the charge inside the membrane, and V out is the charge outside the membrane. Now, if the neuron is at a resting state, this will all be equal to 0. But, say that, it had an internal charge of 50 millivolts, and then the outside charge was 20. Then the membrane potential would be 30 millivolts. Make sense? So that's all for tonight, guys, and this is going to be elaborated on, and I'll extrapolate it on more on it later. But if you have any questions or comments, comment under this. I'm really trying to break this down and simplify it into small little bits for everybody. So, hope you have a good night. Bye, guys.